Hi, let's go ahead and look at how we would work out a problem with proportions. So the problem states that the mail order company advertises 90% of its orders within 3 working days. You select an SRS of 100 for an audit. The audit reveals that 86 of these orders were shipped on time. That is 86%. What is the probability that the proportion of on-time orders is 86% or less? All right, so the first thing is let's pick out what is our population proportion, what is our sample proportion. So over here, the 90%, this is our population proportion P. And the 86% right here, that is our P hat. That is a sample proportion. So looking at the distribution, if we were to take a sampling, in other words, a size of 100, and we were to do this many, many, many times, we would have a sampling distribution. So I drew the model here where our population proportion would be the same for our sampling proportion. So this is our P right here. And our P hat is 86%, which is right here. And they are asking for what is the distribution that is 86% or less. So all of it is shaded here on the left. So the first thing we want to do is state and check the conditions. And of course, draw your model. So my model is my mean, or my sampling proportion is going to be equal to my population proportion, 0.9. Standard deviation is going to be the square root of 0.9 times 0.1 over 100. That is 0.03. So let's take a look at the next thing. What we want to do is state and check our conditions. All right, so the first thing to do when we're answering this question is to state and check conditions. So the problem stated that it is an SRS. So sometimes it's not always going to state that it's an SRS, but it needs to be random of some sort. So we're going to say that that was first condition is met. The next condition is we need to show that our NP is greater or equal to 10. That means our success, so our proportion, which is right here given, is 90%. So if we do 100 times 0.9, we get 90 is greater or equal to 10. That works out. And then same thing for failure. Remember, success and failure always add up to 100%. So 0.9 is a probability of success. That means 0.1 is a probability of failure. We're going to multiply that by 100, and that is also greater than or equal to 10. So our first two conditions are met. The third condition is we want to show that the population is greater than or equal to 10 times n. In this case, n is 100, so that equals 1,000. And what we would say is there is more than 1,000 orders in the population. We will say condition met, and we will use a normal model. All right, next we are going to look at where it is on the curve. So if we take a Z-score, we have the Z-score is always going to be statistics minus parameter over standard deviation of statistic. Now you're better off using words than symbols because you can't go wrong with the words, but if you mess up on your symbols, you will be docked points. So P hat is our statistic right here. That is our statistic. Our parameter is our population proportion, which is P, and the standard deviation is right here. So calculating, putting the numbers in, and we get a Z-score of negative 1.33. Now going back to one slide, you'll see that makes sense. Because when we drew our model, we could see that our Z-score here at the mean, that would be 0. So our mean here, Z-score is here, negative 1 is right here, and this Z-score right here is negative 1.33. Have singing here happening in the house, so I don't know if you hear that. And we want everything shaded to the left. All right, so now to answer the question, you can use a table where you have your probabilities, or you can use some type of calculator. In this case, your calculator can tell you if you use norm CDF, you're always going to have first for norm CDF your lower bound, so we have our lower bound, and then we enter our upper bound, and then the mean, which in this case is our P, and the standard deviation, which in this case is our PQ over N. Entering those numbers in, we have that our lower bound is negative infinity, or you can put just negative 99999. Our upper bound is the value right here, which was 0.86. So it is the 86%. So be careful, don't put it as 86. You have to put it as 0.86. So I'm going to go ahead and write 0.86. And then our population proportion here, that is 0.9. And our standard deviation comes out to 0.03. When you take that area, that is going to equal to this shaded region right here, which is 9.12%. So then you always answer the question in a complete sentence by saying the probability that the proportion of on-time orders is 86% or less is 9.12%. And that pretty much concludes the problem.